Welcome to Across the Globe. Today, we will learn about supervised learning basics. Supervised learning involves training algorithms with labeled data containing input-output pairs, aiming to learn patterns or rules to map inputs to the correct outputs. For example, in a spam email classification task, the algorithm uses labeled emails, inputs, with their respective spam or non-spam labels, outputs, to learn distinguishing features and make predictions on new, unseen emails. By iteratively adjusting its model based on the provided labeled examples, the algorithm improves its ability to generalize and correctly predict outputs for new inputs. In machine learning, training data is utilized to train the model by providing input-output pairs. The model is the algorithm responsible for making predictions based on the training data. To gauge the model's performance, a loss function is employed, measuring how well the model predicts the outcomes from the training data. For instance, in image recognition, training data could be a dataset of images labeled with corresponding objects. The model could be a neural network, and the loss function would quantify the disparity between the predicted object and the actual object in the training data. This process aids in refining the model's predictive capabilities. Regression involves predicting continuous target variables, like estimating house prices based on features such as square footage and location. On the other hand, classification focuses on predicting discrete target variables, such as sorting emails into either spam or non-spam categories based on content analysis. Both techniques are crucial in machine learning for various data analysis tasks. To create a linear regression model using scikit-learn, follow these steps. 1. Import the necessary libraries such as NumPy and linear regression from sklearn.linear-model. 2. Prepare your training data with independent variables features x and target variable output y. 3. Instantiate a linear regression model. 4. Fit the model with the training data using the fit method. 5. Make predictions on new data by calling the predict method on the model. For instance, in the given code snippet, a linear regression model is trained with x = 1, 2, 3 and y = 2, 4, 6. After training, the model predicts the output for a new data point, x = 4. The predicted output will be printed for this input. This process serves as a fundamental example of building and utilizing a linear regression model for predictive analysis. To begin, we import the necessary libraries, load iris from sklearn.datasets and kneighbors classifier from sklearn.neighbors. We load the iris dataset using load_iris function and store the input data as x and the target variable as y. Next, we instantiate a k-nearest-neighbors classifier model with kneighbors classifier. We then train our model on the dataset using model.fixy, x, y to learn the relationships between input data and corresponding targets. After training, we can use the trained model to make predictions on new data. In this case, we predict the class label for a new data point, 5.1, 3.5, 1.4, 0.2, with model.predict. Finally, we print out the predicted class label using iris.targetNames prediction, where iris.targetNames gives the names of the classes in the dataset. Supervised learning is like having a teacher guiding students in a classroom. The teacher provides examples, training data, and correct answers, labels for the students to learn from. Students' algorithm use the examples to make predictions, answers on new problems, test data. Just like how students apply their learnings from the teacher in different scenarios, the algorithm applies its training on new data to make predictions accurately. Hey, Code Conquerors, ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The code exemplifies a supervised learning process using Python's scikit-learn library. The logic pertains to training a model to interpret patterns within a dataset through the supervision of labeled data. Initially, the code imports essential libraries for data manipulation, model creation, and performance assessment. Then, it loads the renowned iris dataset containing flower feature information like petal and sepal dimensions, stored in X, and the corresponding flower species labels in Y. The dataset is divided into training and testing subsets via the train-test-split function, with 20% of the data earmarked for testing to evaluate the model's generalization capabilities. Subsequently, a logistic regression model, a popular linear classification algorithm, is instantiated. Proceeding, the model is trained on the training set using the fit function, where it learns to discern patterns and relationships between the features and labels. Upon training completion, the model is ready to infer on unseen data. By using the trained model to predict flower species for the test data, the code calculates the model's accuracy on this new data. The accuracy, which indicates the proportion of correctly predicted labels, is computed using accuracy score and displayed in a human-readable format. Analogously, this process mirrors the concept of a teacher guiding students in a classroom. Through the iterative process of learning from examples, the model extrapolates patterns and provides accurate predictions, akin to how students would solve problems using learned concepts. One real-world application of supervised learning basics is in email spam filtering. By training a supervised learning model with labeled data where emails are classified as spam or not spam, the model can learn patterns and characteristics of spam emails to predict whether new incoming emails are spam or not. This helps in automatically filtering out unwanted emails and keeping the inbox clean for users. Another example is in healthcare, where supervised learning is used for medical image analysis. By training a model on labeled medical images, such as X-rays or MRI scans, the model can learn to detect patterns or anomalies indicative of diseases or conditions. This assists healthcare professionals in diagnosing and treating patients more effectively by providing additional insights and aiding in early detection. Supervised learning techniques are widely employed in various industries and domains to make data-driven decisions and predictions, showcasing its versatility and importance in today's data-driven world. Keep learning, stay curious, and I'll catch you in the next video.